Can somebody explain why this is wrong? Okay, let's take a look. So here we are talking about the limit as x approaching 0 of x times sine of 1 over x. So this is what happened. Right here, if we bring this x down, then we are going to get the limit as x approaching 0, and we get sine of 1 over x, and then over, again, x down, so it's 1 over x like this. What do we do next? Well, we see that this input and our input are the same, and there's a very nice theorem says if they are the same, the answer is just going to be equal to 1, right? Well, this right here is actually incorrect. The reason for that is because here, x is approaching 0. When that happens, here, this is actually going to become infinity, well, plus or minus infinity, and this right here is going to be same thing, plus or minus infinity. It does not work. What's the correct version is that the limit as, let's say, x approaching 0 of sine x over x. This right here is indeed equal to 1. And now, if you put 0 into this x, this gives you 0, and this right here gives you 0. But it's not because 0 divided by 0 is equal to 1. There's actually a geometric proof on why this is equal to 1, and we can talk about that later. Here, how exactly do we evaluate its limit? Let's have a look. Here's the first thing that we should do. Plugging 0 into all the x's and see what happens. When that happens, we get 0 times sine of 1 over 0. And now it's like, 0 times anything is just equal to 0, right? Well, not quite. Because if you look at this part right here, we have to be extra careful. Okay, so let's say if you are just working with 0 plus, meaning we go approach 0 from the right direction. Because this way we can say that inside 1 over 0 plus gives us infinity. And the sine of infinity actually does not exist. And the reason for that is because if you look at the sine function, it goes up and down like this. There's no horizontal asymptote, so it does not approach a finite number for this. And you might be wondering now, 0 times dne, is this just 0? Technically cannot say that. Yeah, so be extra careful. Here's the deal. When this kind of things happen, if you see 0 times something, we're actually going to set up some bounds. And that's the idea of using the squeeze theorem. So let's have a look. And the idea of using the squeeze theorem is that we will be working with some inequalities. And the key is the sine function. It's in between of -1 and +1. So here's the note. I can write sine theta. And if we apply an absolute value, we know that will always be less than or equal to 1. And this is true for all theta in the real numbers. We have 1 over x. That will be for sure satisfy this as well. So here's the observation that we are going to make. Observe that if we apply the absolute value to sine of 1 over x, this will always be in between of -1 and 1, which is absolute value is going to be less than 1. Now, we are missing the x. Well, I can multiply both sides by x, but remember x is approaching 0, so technically we have to check both directions, the positive direction and also the negative direction. If x is approaching 0 from the negative direction, then when we multiply both sides by x, we will have to flip the inequality. So we technically have to break down two cases. But it's okay, because we can just do the following. Why don't we multiply both sides by absolute value of x instead? That works too. And since this is always positive, well, this is never negative, I should technically say that, because sometimes it can be 0. But well, x is not equal to... And since absolute value of x is never negative, I don't have to worry about the inequalities. Here, the absolute value of a... And since absolute value is never negative, we do not have to worry about the inequality. Right here, the product of the absolute values is the same as the absolute value of your product, meaning I can just put the insides together and multiply them. And we know that will be less than or equal to absolute value of x. And because we have absolute value right here, we know that this part is always going to be non-negative. So we have this thing right here. Now, looking at this, go ahead and take the limit as x approaching 0 So I'm doing this to here, here, and also here. The limit of 0 as x approaching 0 is for sure equal to 0. And the limit as x approaching 0 of absolute value of x is just, this is continuous. So you get LOL, right? Absolute value of 0. You get 0. So we can say that will be 0 as well. And in the middle is exactly the limit as x approaching 0 of the absolute value part. And as you can see, the left hand side is 0, the right hand side is 0. The only way for this to be true is that this thing has to be exactly 0. And now we can quote that by the squeeze. And this time I'm going to spell it correctly. E-E-Z-E by squeeze theorem. Alright? And now you might be wondering, good, this is the limit, but here we have the absolute value though.